mentioning the utilization of the spin properties, I just wanted to, these are kind of also seminal papers where this is somewhat demonstrated. So this paper demonstrating that you can use microwaves to modulate the fluorescent signal of the NV center with time. And in general, what this allows you to do is to get background-free imaging. If you have tissue autofluorescence in the background, you can then modulate your fluorescent signal of the diamond particles and generate you get much higher confidence in what you're looking at, essentially. And then in addition to microwave modulation, this magnetic modulation demonstrated in 2014 also allows you to enhance the visibility. So these are lymph nodes with diamond, and then magnetic modulation allows you to enhance your contrast. Last couple slides, I just wanted to demonstrate the possibility of sensing applications of diamond. So intracellular sensing, in this example, they're measuring temperature fluctuations within the cell. So essentially what this is showing is you have gold nanoparticles, which they then hit with a laser, they radiate heat, and you have an NV center, or a diamond containing NV centers here and at slightly larger distances. And you can actually measure the temperature change. And of course, it's a function of distance away from the spot which you're heating, and in general here. But you get this 1/10 of a Kelvin or so sensitivity within the cell. So it's quite interesting. In addition to just temperature sensing, there's the potential to sense electric fields. So for example, neurons firing, for example. In general, these applications are all kind of emerging, and everything needs optimization, but it's a very interesting perspective for diamond. And the last application, and this has become quite popular recently. So it's effectively using the spins, or the ability to polarize NV centers to a very high degree at room temperature. And then you can then transfer the spin to external molecules, or for example, in this case, this group at Berkeley, Ashok, Ajoy, and they do polarize the NV center and transfer that spin to carbon-13 within the diamond lattice, and then the carbon-13 polarizes external nuclei. So in general, what this can allow you to do is improve, in the case of NMR, it's improved sensitivity. And in the case of MRI, in theory, you can use much lower magnetic field strengths to get the same benefit. And ideally, that will hopefully be an application that will come to light, especially in point-of-care therapy and smaller hospitals, for example, which can't afford a multi-million-dollar MRI machine, right?